Objective: to understand the characteristic properties of a wave. We know that light propagates in the form of electromagnetic waves, and that an electromagnetic wave is propagated by the oscillations of electric and magnetic fields. Now, let's study the characteristic properties of a wave. A continuous wave consists of several peaks, or crests and troughs. The important characteristics of a wave are wavelength, frequency, wave velocity, wave number, time period, and amplitude. Wavelength. Observe the pattern of the wave. You can see that the wave is made up of several crests and troughs. The distance between any two successive crests or troughs of a wave is called its wavelength. It is represented by the Greek letter lambda. Wavelength is expressed in the terms angstroms or nanometers. 1 angstrom is equal to 10 raised to the power minus 8 centimeter and equal to 10 raised to the power minus 10 meters. 1 nanometer is equal to 10 to the power of minus 7 centimeters and equal to 10 to the power of minus 9 meters. Frequency. Frequency is how often a wave cycle passes through a given point per second. A wave cycle is a single up-down motion in a wave. So, we can consider a wave to be a series of such wave cycles. Now, consider a point on the line in space. When a wave moves through this point, a certain number of wave cycles can be observed to be passing through it in unit time. The number of waves or wave cycles passing through a point in unit time is called the frequency of the wave. It is represented by the Greek letter nu. Frequency is expressed in cycles per second, or CPS, or second to the power of -1 or hertz. Let's now understand the relation between wavelength and frequency of a wave. Consider two waves with different wavelengths. As you can see, the wavelength of the first wave, lambda 1, is greater than the wavelength of the second wave, lambda 2. Let's observe the frequency of waves moving with same speed. Each wave flashes when it crosses the line. We observe that the wave with shorter wavelength flashes more frequently than the wave with longer wavelength. Hence, frequency of the wave with shorter wavelength is higher than so it can be said that frequency of a wave is inversely proportional to its wavelength. Therefore, velocity of a wave is equal to the product of its frequency and wavelength. Please note that all electromagnetic radiations move with the same speed, that is, the speed of light in air or vacuum, which is equal to 3 × 10 to the power of 8 meters per second. Wave number. Observe the waves. Do you see that in the first case there are 2 wave cycles traversing the distance x, and in the second case there are 4 wave cycles traversing the same distance? The number of wave cycles present in unit length of a wave is called its wave number. It is represented by nu bar. Wave number is also defined as the reciprocal of its wavelength. Wave number is expressed in terms of per centimeter or per meter. Time period. Count the number of wave cycles crossing the given point in 5 seconds. Do you observe that 5 wave cycles pass through a point in 5 seconds? It implies that the time taken for one wave cycle to pass through the given point is 1 second. This time is known as the time period of a wave. The time taken by a single wave to pass through a given point is called its time period. The reciprocal of the frequency of a wave is also known as its time period. T equals to 1 by nu implies T equals to lambda by c. Time period is generally expressed in seconds. Amplitude. The maximum displacement of a wave from an imaginary horizontal line passing through a wave is called its amplitude. A. Amplitude is also defined as the height of a crest or depth of a trough. In the given wave, OP and O-Q represents the amplitude of the wave. Amplitude is generally expressed in meters or centimeters. Let's summarize what we have learned. A wave consists of several peaks or crests and troughs. The distance between any two successive crests or troughs of a wave is called its wavelength. The number of waves or wave cycles passing through a point in a unit time is its frequency. Velocity of wave is equal to the product of its frequency and wavelength. The number of wave cycles present in a unit length of a wave is called its wave number. The time taken by a single wave cycle to pass through a given point is called its time period. And the maximum displacement of a wave from its mean position is called its amplitude.